Okay, very good morning to all. So today we will complete the already we have discussed yesterday. We started the unit 6, right? So multi-way trees. Okay, Gaurav. Screen is visible to all. Is it visible properly?
Yes, sir.
Okay. Now, unit 6, multi-way trees. So yesterday we started the discussion, and I think most of all the points we have completed. So few points we will discuss today, and after that we will move to the next unit, unit 7, height balance trees. So 6.1 is the, in that we discussed about the what is mean by multi-way search trees. I hope all of you understood the concept of multi-way search tree. After that, we discussed about the balanced multi-way trees, right? And next one is the traversing a multi-way tree. So I think this point we have not discussed. Traversing, have we discussed or not? Okay, so this traversing a multi-way tree, so that we will discuss. And next is the insertion in multi-way trees. So B tree and B plus tree. So these 2 points we have covered, right? So I hope all of you have understood the B tree and B plus tree. So is there any doubt or is there any questions? So whatever the point yesterday we have completed. So is there any question or is there any doubt? So you can ask. Offline student also. That problem I have. So whatever the point we discussed yesterday, I hope all the points you have understood. Now next point. So before proceeding to the next point, traversing a multi-way tree. So first we'll discuss the what is the difference between the B tree and B plus tree, right? So I hope if you have understood the concept of B tree and B plus tree, so definitely you are able to differentiate the B tree and B plus tree. So I'm expecting the answer from your side, and after that we will discuss the next point, that is the traversing of multi-way trees. So what is the difference? B tree, in the B tree we are traveling from root to bottom, okay, and in B plus tree from okay, in B plus tree, so we are considering only the for the searching or for the insertion, for the searching purpose, most probably we are considering the leaf nodes only, right? So which is present at the last level. After that, next one is the so where data is stored, regarding the data. Now we'll see the first difference regarding the organizational structure, right? So whatever the difference you said, so the difference is same, is applicable for the organizational structure. So structure of the B tree is, so we are assigning all the keys we are considering at respective level or at the same level only. Suppose for example you have placed the keys, or if you have considered some keys, so that key you have stored in a root node. So in the B tree, we are considering the, or we are maintaining the storage and everything at the same level or in the same node. But in B plus tree, what you are doing? So you are storing the all key values at the leaf node only, right? So this is the first difference. This is the organizational structure related difference. Where is your friend? Those who are attending the offline classes, so I have circulated one attendance, so you can write your roll number, division, and name, and in front of your name. So do the signatures, right? Now again, how you are maintaining the leaf nodes in B plus tree in your organizational structure? In B plus tree. So how it is maintained? Means, are you connecting the nodes with each other, or is there anything? In the leaf node, you are connecting the one leaf node to the another leaf node. So by using the links, right? So what is the main purpose of linking this leaf node? What is the purpose?
Traversing.
Traversing, right? So traversing purpose, or it will be very easy in case of searching, right? Now when you are searching the element, so how you are searching? So you are checking the in the first block, so greatest element you are comparing with the what element you want to search. So that element you are comparing with the first block greatest element, after that second block greatest element. So if it is less than that greatest element, so you are searching in the respective block, right? So what is the benefit of B plus tree? What is the benefit? Yes. Hello. First benefit is the when you want to search any element, no need to travel from the root. Good. Next difference. Again, regarding the time, is there any time? Again, yes. So for the B plus tree, so you require the less time, and searching is faster and easy as compared with the B tree. So these are the basic difference you need to remember, right? And also, so B tree is identified by using the balanced tree, and B plus tree is identified by using the balance of plus tree, right? So again, regarding the storage, storage once again. So whatever the key values, so in the B tree we are storing at respective node only, and in B plus we are storing at the A, right? Now here regarding the function of leaf node. In B plus tree, so leaf node stores the data by considering the linked list concept, right? But in B tree, so leaf node is not storing the data by considering the linked list concept, right? Now, regarding the redundancy, is there any redundant key? Redundant means duplication. Repeatedly we are using. Redundance means, so repeatedly we are using the keys. So where redundancy is coming? B plus tree. But in B tree, is there any redundancy? No, right? Because in the B tree, we are considering a key at only one time, right? But in B plus tree, so suppose the key you have stored in root, so same key you are storing in a leaf node also, right? So this is the main difference, or in the B plus tree. So this is the disadvantage of B plus tree. So redundancy or data redundancy will be there in a B plus tree, right? So these are the basic differences. So you need to consider. And after that, now we'll start with the which part we have completed. Traversing. So multi-way traversing. So here I will draw some diagrams, and I'm expecting the traversing path from your side. So right. So is it visible to all? So online students, so you can click on the camera, so it will be visible for you. Already pin केलेला आहे मी. आलं का? So here I will draw the tree first, and by observing this tree, so I'm expecting the traversing path from your side, right? Eight. So here, can I store the at left side? So more than 11? No, less than 11. Whatever the values I'm considering here. So online students, so don't unmute yourself. So if you unmute, so automatically the screen is changing, right? After that, so next one is the middle, so only 15 minutes. Twenty-seven, 32, 14, right? And here is the is it visible to this? Otherwise, you can sit here. You can sit in this room. First, या साइडला बसा इथं दिसते काय बोर्डवरचं दिसतंय का तुम्हाला क्लिअर याच्यावर ठीक now we can extend the traversal techniques of the binary tree to multi-way search trees here, but here order is 2 na? Right, so here I have considered order is 2 only, so in that case you can store the single key. So this minimum key value is totally depends on value of m or value of orders. So here order is considered as a 2. Now we have seen the traversing techniques in binary trees, right? So how many traversing technique you are using in a binary trees? Which traversing technique you have used? In order, pre-order and post order. Same we will use here for the traversing purpose, right? Now here for the in order, so how you are visiting for in order?
Left root right.
Left root. Yes, online student.
Left root right.
Left root right.
Left root and right. Okay. Good. Next. For in order, sorry, in order we have discussed. Pre-order.
Root left right.
Root left right.
Root left right. Okay. And for the post order?
Left right root.
Left right root.
Right.
Okay. Now, so all of you are having the notebook, right? So offline students and online students, so you can use the chat box or you can use the your notebook. So here I'm expecting the answer from your side. So this is the tree. Now I'm expecting the in order of the given tree. So in order. After that, pre-order. And next one is the post order. Now, what is the in order of the about tree, right? And what is the pre-order of the this tree? And what is the post order of the this tree? So all of you have calculated the in order, pre-order, and post order. So online student, so you can share your answer in the chat box, and offline student, so you can write in your notebook now. Or those who are attending online, so you can use the notebook and pen and write down the answers in order, pre-order, and you can share it on a group. Now, within 2 to 3 minutes, I'm expecting the answer from you. Also, project promotes like this. Mobile में किसने all of you have completed. So what is the in order? Hello, online students. In order is 2, 6, 8.
11.
Kyle in order 2, 6, 8. After that 11.
11.
After 11 15. Good. 15. Next 24.
24, 27.
27, 30.
Next is the 27, 30, 32 and 40. So all of you got the same answer for the in order.
Yes, sir.
Okay.
Yes.
Next pre-order. What is the pre-order?
11.
11, 2, 6, 8.
15.
Next is the 15, 24,
24. 27.
27,
7.
30,
32,
32 and 40. Good. All of you got the same answer for the pre-order?
Yes,
Yes,
sir.
sir.
Okay, good. Post order.
268.
268.
268,
15 and 11.
268, 15,
11.
11, नंतर 30,
40,
27,
27, 32,
32,
14,
40 and
27,
24.
32, 40, and 24.
24.
Good. So one more example we'll see, and after that we'll move to the next unit. So this is the second example. Now all of you calculate the in order, pre-order, and post order for the second example. All of you unmute yourself. Sorry, mute yourself. ये कौन है ये? पूरा- All of you have completed. So what is the in order? In order sanga. 1, 2, 3, 4, 5,
4, 5,
7, 8,
7,
9, 10, 12, 13,
12,
and
13, 21.
21. So all of you got the same answer? Yes.
Yes, sir.
Yes, sir.
Pure madam. आलो काय आन्सर अजून सॉल्व करताय प्री ऑर्डर नेक्स्ट प्री ऑर्डर 9
9, 3, 1,
9 3 1 2
2,
after that 4 5
4, 5, 7,
7
8,
8
13,
13
10, 12,
10 12
21.
21 good. This is the pre-order. So I hope all of you got this correct answer or same answer. Next, post order.
1,
1, 2, 4, 5,
1 2 4
5,
5,
5 3
3,
8
7,
10 12
10, 12, 21,
21
13,
13 and
9, 9.
Good. So I hope all of you got the same answer, right? Now here multi-way traversal point is completed, and here we have completed all the points of unit number 6, multi-way trees. So multi-way search tree we have completed, balanced multi-way tree we have completed, traversing a multi-way tree, so that part also we have completed. And next one is the insertion in multi-way tree, that is B tree and B plus tree. So both point we have completed. So is there any question related with these points? Still, is there any point you have not cleared? अजून यामधला कोणता पॉइंट समजलेला नाही असा आहे का? So related with the unit 6, so I want to give you some assignments. So you need to construct the B tree and B plus tree. So here I will give some examples. So for you as an assignment, right? And after that we'll move further. We'll start the next unit. So first, all of you dictate in your notebook. So first assignment is insert in B tree. Insert in B tree. So all of you dictate it in your notebook. Insert in B tree of order 3. Of order 3. Insert in B tree of order 3. Order 3 means, so whose value you are considering? M is equal to 3. So what is the minimum keys you are considering
2,
for the internal nodes?
One.
One consider करणार का 2 consider करणार?
1,
1,
1,
Cell value consider करणार का floor value?
sale,
Sale.
B3. So I am talking
sale, sir.
1, right? 1 is required, right? So here the value is 7, 6, 2, 11, 4, 8, 5, 50, and 12. So this is the first example. This one is first, second. So order is 5. Same B3. Order is 5. And the values are so 3, 40, 7, 1, 8, 5, 11, 17, 13, 6, 23, 12, 20, 26, 4, after 4, 16, 18, 24, 25, 19. Third example, is it visible? Not this thing. Order 4. Insert. Here also say insert. Five, 3, 21, 1, 2, 3. Now, all of you have dictate this assignment in your notebook or take a quick shot of the same. Now, you have to complete this assignment up to today evening. These 3 examples you need to, by using these 3 value, you need to construct the B trees, right? Now for the B plus tree, so again 2 examples for the B plus tree. Which example we have discussed here? कौन सा discuss किया लोग अपन? I think 40, 109, 15, I think like this we have discussed, right? So another examples I will do for the evaluation. All of you have dictated? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Next one is the example for B plus T. So directly I will use the example insert. One, 3, 5, 7, 9, 2, 4, 6, 8, 10. And here order is equal to 4. This thing, so is it visible? Second example, you need to consider insert 1, 4, 7, 10. Is it visible? 42. This thing, last value 42 is visible.
Yes, sir.
Mobile में this thing. Yes. कोण आहे ए कोण आहे अनम्यूट केल्यानंतर here so order is 4. Order 4. I think 5 examples are sufficient so for your today's assignment. Now here in this way we have completed the unit number 6. So multi-way trees. Now we'll proceed further with the next unit. Screen share होत नाही. Now next unit we will start. So unit number 7. So height balance trees. So next unit is the height balance tree. Now here in the height balance trees, so we will discuss the AVL trees. So in that we'll discuss the definition. So am I audible clearly to all online student?
Yes, sir.
Okay. So AVL tree will discuss. After that definition, height of and AVL trees, right? So here, so height of AVL tree is very important, right? So meaning of the AVL tree will discuss. What is mean by AVL and everything we will discuss. After that, so generally, so always in our data structure, so how many operations we are performing for every data structure? Insertion, deletion, and searching, right? And if required, sorting. But here in the tree by default we are following the sorting, right? So no need to apply the sorting techniques. So here insertion, deletion, and searching, right? For every data structure we are following these operations. बरोबर आहे. डेटा स्ट्रक्चर मध्ये दुसरं काय आहे का? अल्गोरिदम आहेत, ऑपरेशन सगळे सेम आहेत, फक्त टेक्निक आणि मेथड चेंज होतात. So here in the AVL tree, so what is the new thing in the AVL tree? So we are considering the height of the tree, right? So how to calculate or how to consider the height of the tree in the AVL? So for that purpose, one concept we are going to discuss here, that is the balance factor, right? So we are considering the balance factor. Balance means what you are checking. So I think everyone is aware with the, so what we can call तराजूला काय म्हणतात? तराजू. So Marathi, English मध्ये काय म्हणतात तराजू? So have you heard the tarazu, right? So you are balancing the two things, right? So by considering the weight, so you are putting the weight at 1 kg at one side and at one another side, so you are putting some atoms like sugars or any peanuts and anything, right? So you are comparing the weights, right? So how you are comparing the weight? So you are considering the left and right side of the things, right? And you are handling that things at middle, right? Means here the same real-time approach we are following in case of tree also, right? Same real-time approach we are following in case of tree also, right? So here what we are doing, so we are considering at center root as a center, right? And after that at left side, what we will consider? Left subtree, and at right side we'll consider the right subtree. Online student laksh dete kai hote? So I will draw the diagram so that you will get the concept. So what is meant by AVL line? So is it visible to all? So camera is visible. Online student.
Yes, sir.
Yes,
Yes,
sir.
sir.
So I will draw the tarazu diagram nahi hai, don't laugh on that. Okay, so try to understand. I'm not actually drawing picture, so here at one side you are putting something, right? And right. So here you are putting some atoms, and here you are putting some weights. Right? So weight is like this, right? And what you are doing, so you are trying to balance the things, right? By considering this root, right? So by considering this center, so you are balancing the two things, right? So one is at left side and one is at right side. So same concept we are applying here in the AVL tree. So how we are applying the concept of this real-time concept in our AVL tree? So we have seen how many types of trees till now? Now, before proceeding to the definitions and everything, so we'll discuss the few points. So AVL tree. So in this unit, so what we are going to discuss? So definition, height of the AVL trees, and different operations, right? So when you are performing the insertion and deletion operation, or when you are performing insertion, now to balance the tree, so we need to apply the rotation here. We need to apply the rotations, right? So we'll see the single rotation and double rotation. So how to apply the single rotation and double rotation to create the unbalanced, to convert unbalanced to the balanced tree. So all these things we will discuss here. Now, what is the importance of this chapter? Already we have studied the trees and so many trees. How many trees we have discussed till now? We have discussed the trees, right? So binary tree we have discussed, binary search tree we have discussed. After that, threaded binary tree we have discussed. Next, again, B tree and B plus tree we have discussed. Then what is the purpose of going through these height balance trees? To balance the height of the tree, right? So how we are balancing the height of the tree? So we'll consider the left subtree separately and right subtree separately, right? Now balancing means we are not considering their values actually. So we are considering, to balance the tree, we are considering the height of left side and height of the right side we are considering. And we'll compare the height of left side and height of the right side subtree. And if the height of the both side is same, so then we'll see balance factor is 0. And if the height of the tree is little bit different, suppose sometimes left side will be greater than one level, or sometimes right side will be greater than one level. So at that time, so balance factor will be changed, right? So how to calculate the balance factors and everything we will discuss in detail, right? Now main purpose of discussing this unit, or include why we are going to study this unit. So main purpose is to convert the unbalanced tree into the balanced trees, right? Now we have seen the binary trees. So different type of binary trees we have discussed, right? So scaled binary trees. So what do you mean by scaled binary trees? Left scale and right scale. So we have seen or not?
Yes.
Online student.
Yes, sir.
What do you mean by scaled binary trees? Left scale and right scale. So this type of tree is called as a left scale or right scale? Left scale.
Left.
And this one is of right.
Right.
Right. Right. Now, so this tree is balanced or unbalanced? Unbalanced. Why? Because all these child node is connected at, or child is connected at only left. So no one is present at the right. Right. Here also the same. So all the child node is connected at right, but no one is present in the left. So to convert such a kind of unbalanced trees, so maybe suppose only one is there here. So is it balanced? No. Now I will say.
No, sir.
So now this one. Now this one is balanced.
Yes, sir.
Yes. So how you identified it is a balanced or unbalanced? So what kind of logic you have used here? So technical answer
Both.
I'm expecting. Yes.
Height of tree.
Height of the left subtree and height of the right subtree you have considered. Height of the left subtree and height of the right subtree you have considered, right? Very good. So by considering the height of the left and right, so you are considering the tree is a balanced or unbalanced, right? Now to convert the unbalanced tree into the balanced tree, so we need to study this height balanced tree concept, right? So this is the main purpose. So we are going through the AVL tree. Now, if the tree is unbalanced, so how to convert them into the balanced trees? मध्ये कसं बॅलन्स ट्री मध्ये कन्वर्ट करणार? काय तर जादू लावला. Yes. Something we need to do here. So to convert, suppose this is the left scale or right scale? This one
Left.
Left.
is left scale tree, right? So left scale binary tree. Now I want to convert this left scale binary tree into the balanced tree. So how to convert?
By insertion.
काय करावं लागेल? काय तर मूव करावं लागेल.
Rotate.
Some of the nodes we need to shift at right side.
Right side.
Right. So for that purpose, so we'll use the rotation operation, right? To convert the unbalanced tree into the balanced tree. So we are using the rotation operations, right? Now again, the rotation operation is performed. So single rotation, after that double rotation. Now single rotation is again two types. So left single rotation, right rotations, right? Now where you want to rotate, at left side or at right side, right? Now again, in case of double rotation, yes. Your phone?
Yes. Second.
Yes, regular. Then why you are late? So it's now it's 10:30. Huh?
I have come from Sandra.
So please wear your mask. Because your camera is observing you. So all of you follow the whatever the rules and regulations is given by the university and our institute. So for me, so I'm maintaining the distance. So that's why I'm not wearing the mask. Right. So what we are discussing? How to traverse. So for that purpose, we need to apply the rotation. Now again, the rotation is of different types. So one is the single rotation. First is the single, and after that double. Now single, in the single again, left rotation, right rotation. Now in the double, again left, right, right, left. So these are the types. So we will discuss each and every types, right? Now all of you have got the overview of the unit 7 and what is the purpose, why we need to study the height balance tree unit. Now we'll start with the first point. Is it visible to all?
Yes, sir.
Okay, good.
Yes.
Actually, in the notes, so these notes in the previous semester, so this was the 6th unit. So, but as per our new syllabus, now it is 7th unit, right? So try to understand. So this much modification. Now, height balance tree. So I'll off the camera first. Now, am I audible clearly? So if not, so immediately you can respond me here. Audible. Okay, good. Now, here the tree is just have a simple tree. So you can consider a simple tree. So first tree we have considered as a simple tree. So one root node and 3 child node we have considered, right? Now after that, second tree is a type of which tree? Second, binary tree. So everyone is aware with the rules and regulations related with the binary trees, right? So binary tree is using the childs like 0, 1 and maximum 2 child is allowed in the binary tree, right? After that, binary search tree. Now in the binary search tree, what we are following? So we are following the ascending orders of the key values. Okay. But in binary tree, you can store any values that will be allowed. But in binary search tree, so we need to follow the ascending order. So whatever the element you are storing, so to the left side, so they are less than the root, and whatever the element you are storing at right side, so they are greater than the right. Right. Now after that, next tree we have discussed multi-way search tree, right? Now height may be anything, and in which each node is containing only one key, right? Now as the height is more, it takes more time to process. Now what is the drawback? Why we need to go for the to convert from unbalanced to balanced? काय गरज आहे हे सगळं करायची? चालत नाही का unbalanced? If the height of the tree, if the tree is unbalanced, means obviously height of the trees get increased, right? Now, if the height of the trees get increased, so what will be the drawback?
Takes more time.
It takes more time. Very good. It takes more time, or it requires extra time, right? To search any element or to perform any operations. Any operation you want to perform, like insertion or deletion or searching, right? So to perform any kind of operation, it will take a extra time or maximum time, right? So to reduce these kind of problems or these kind of shortcomings, so we are converting our unbalanced to the balance, right? Now how to convert? It is done through the help of M-way trees, that is multi-way trees. And here, so we are considering the height balanced subtree. Now PDF is visible to all?
Yes.
Online student, is it visible? Okay.
Yes. Yes, sir.
Now a binary tree of height h is completely balanced. So if all leaves occurs at the node of the level h or h-1, right? So here the one tree is given, and the levels is given, so not more than that. Now we'll move to the next very important point, that is the how to calculate the balance factor of the tree. Now how to calculate the balance factor of the tree. Now each node of an AVL tree has, just 1 minute. Now here, last paragraph, so we'll go through the last paragraphs and after that we'll move to the next one. Now, almost height balance tree is called as a AVL tree. So who defined this? So Russian mathematician GMA, right, and studied this form of trees. And AVL tree may or may not be particularly balanced. So AVL tree is a balanced binary tree, right? AVL is also binary tree, right? But AVL is a balanced binary. So how to balance? So for that purpose, we need to consider the point, that is the balance factor. Now how to calculate the balance factor? So very simple one. So just you go through the definition, so you will get the clear ideas. So who will read it? Each node of an AVL tree has the property that the height of the left subtree is either on more, equal, or less than the height of the right subtree, right? And what is meant by balance factor? Simple definition. Balance factor is the difference between the
Height of
height
left
of
sub
left subtree and height of
right
right
subtree.
subtree. So is there any difficulty to calculate the balance factor of the tree? BF is equal to height of left subtree minus height of right subtree. Now everyone is got the concept how to calculate the balance factor. Now, so when you are after calculation of balance factor, so which value you are considering for the balance tree? So if the balance factor in the AVL tree can take 3 possible values, so which one? So if the balance factor value is either 0, 1 or -1. So out of these 3, so if any value is there for the BF, so you can say this tree is a balanced tree. Balanced tree कुणाला म्हणणार आहे आपण? ज्या ट्रीची BF value 0, 1 or -1. So out of these 3, so if any value is there, so you can say this tree as a balanced tree. And if the value of BF is 2, 3, 4 or -2, -3, -4, so at that time we need to perform the rotation operations, or we'll say the tree is an unbalanced tree, right? Now all of you got the concept. So when you are saying the tree is a balanced, when you are saying tree is a balanced, if the value of BF is 0, 1 or -1, right? Now, so you can see here the one tree is given. So balance factor is equal to -1. So if the height of the left C, so here you can see the example. So in the example, so D, G, C, E, H. So this tree is given. So what is the height of left subtree here? What is the height of left subtree? 1. 1. And what is the height of right subtree?
2.
2. Right. Now use the formula of balance factor. So 1 minus 2. -1. Now all of you remember. So how you are writing now? What is the balance factor of C? What is the balance factor of C? C is a balance factor क्या?
0.
0.
0. Left right आहे का त्याला? नाही.
No.
Now what is the balance factor of E?
0.
What is the balance factor of H?
0.
And what is the balance factor of G?
0.
Why balance factor of G 0?
1 minus 1 0.
1 minus 1 0.
0.
Now what is the balance factor of D?
-1.
Right.
1 minus
Now-
2 minus 1.
Okay, good. Now can we say this tree is a balanced or unbalanced?
Unbalanced.
Unbalanced.
Balance.
Balance.
Balance म्हणणार आहे, right? So why we are saying balanced?
Because BA factor is -1.
Balance factors are 0, 1 and -1 असेल तर. So we are saying the tree is a balanced tree, right? Now here AVL tree is a balanced tree. Now we'll see the another example. Now second example. Is it visible to all, everyone?
Yes, sir.
Yes, sir.
Second one is the BADCGEH. Now what is the balance factor of E?
0.
0.
H?
0.
0.
E?
0.
D?
0.
-1, sir.
-1.
1 -2 -1.
A?
0.
And B?
-2.
Minus
Now the above tree structure is balanced or unbalanced?
Unbalanced.
Why you are saying unbalanced?
Balancing factor is
-2.
Balance factor is -2. So that's why you are saying it is a unbalanced, right? Now next example. So 10, 8, 15, 7, 9, 12 and 18. So this tree structure is balanced or unbalanced?
Balance.
What is the balance factor of all the trees?
0.
0. Now what is the balance factor of previous trees? Root node the balance factor किती आहे?
-2.
-2. आणि त्याच्या अगोदर एक एक्झाम्पल बघितलं.
-1.
-1.
Right. Now all of you have got the concept of balance factor, how to calculate the balance factor.
Yes, sir.
And with the help of balance factor, we are deciding the tree is a balanced or unbalanced. Next, one more example. So we'll see these examples and after that we'll move to the rotation parts. Next, balance factor 1, GEHC. What is the balance factor here?
1.
1. The tree structure is balanced or unbalanced?
Balance.
Balanced. Okay. Next example, XGYEHCF. This tree structure is balanced or unbalanced?
Unbalanced.
Unbalanced, right? So what is the balance factor here?
2.
2.
2. Now we'll see the operations on AVL tree. Balance factor सर्वांना समजलं? सर्वांना समजलं का? Add sir. This side.
Yes, sir.
And next we'll see the operations on AVL trees. So first one is the insertion, deletion and searching. Now algorithm for the insertion. So first we'll start and after that, so first we'll check. So what you need to check? So when you are inserting any element, when you are inserting new node, empty or not, so delete च्या वेळी ती condition compulsory आहे. इथं फुल वगैरे काय आहे? AVL tree आहे. ट्री मध्ये आपण चेक करतोय का? In the stack or in the queue or in the linked list. So at that time we need to check the conditions, right? Already we are providing the size of the list. But here, so this AVL tree is a linear data structure or non-linear data structure?
Non-linear.
Right. So is there any restriction for the size? Size साठी काय restriction आहे का? नाही.
No.
Because this is the non-linear, right? Now first, then what we need to check here? So we are checking the empty condition. If the AVL tree is empty, so then make a new node as a root node, right? So if the tree is empty, so if you are inserting first node, so obviously, so first node will consider as a root node, right? Now after that, so for the remaining element, so what you are doing, so remaining elements are inserted by using the following steps. So first step, so compare new node with the root node. Compare new node with the root node. Now, if the new node is greater than the root node, so where you are storing? At the right side. So then insert it into the right side of the root node. And if the new node is smaller than the root node, at left side. Simple. So here we are following the binary search tree root. Now, after completion of insertion, so what you are checking? Now
Balance.
here one more point is added. So always, every time we are checking the balance factor after insertion of element. So after completion of insertion operation, so if the balance factor in the AVL tree is in between 0, -1 and 1, so then no need to do any kind of adjustment, right? Now if balance factor is except this 0, -1 and 1, so any other values except these three, if the balance factor is, or simply will say if the AVL tree is unbalanced after inserting the element, so what we need to do? So we need to do the adjustment. So for that purpose in the else, so what kind of logic we need to use for the adjustment? So using the following steps. So first step we'll use for the adjustment, that is the single rotation, or you can use the double rotation. Now when you need to go for these steps, rotation ला कधी जाणार आपण? ट्री अनबॅलन्स असल्यानंतर. आणि अनबॅलन्स हे कधी चेक करतो आपण? बॅलन्स फॅक्टर कधी चेक करणार? Every element. So after insertion of every element, we are checking the balance factor, right? Now here, so you need to repeat the step 3 and 4 till inserting all the elements. So these kind of steps we are following when we are inserting the element in the AVL trees. So what is the change here? So if we compare with the previous one, only the thing is balance factor we are checking, and if the balance factor or if the tree is unbalanced, so we are doing some adjustment, right? And by doing that adjustment, we are converting that unbalanced tree into the balanced tree, right? Now we'll see how to perform the single rotation and double rotation, and after that we'll go through the examples. Is it visible? Operations of AVL tree. So if AVL trees are unbalanced, so then make the rotation of AVL trees. Now types of rotations. So there are two types of rotations in the AVL trees. So first is the single rotation and second one is the double rotation. Now in the single rotation, the rotation again divided into two types. So first one is the left rotation and second one is the right rotation. Now all of you give attention here. So how to perform this rotation? You need to understand the concept of rotation. So if you do the mistakes in the rotation, so definitely you will get a wrong answer. So this concept is very important. So whatever the part we discussed, so this part is very simple one. So you are able to understand easily. Now this rotation part is very important. So first left rotation. So example is given, right? Now in the example, so these A, B, C. So what is the balance factor of C here?
0.
Balance factor of B?
-1.
Balance factor of A?
-2.
-2, right? Now here, so how to apply the left rotation? Left rotation म्हणजे काय? This is the right subtree. दिस इज द राईट सबट्री. ही कुठली सबट्री आहे? राईट सबट्री आहे. ठीक आहे. आता त्याला काय करायचं आपल्याला? वी नीड टू रोटेट देम इनटू द विच साइड? Left side.
Left side.
Now here, now when you are observing or when you are performing the insertion operation, so how to identify the which rotation is applied? हे कसं आयडेंटिफाय करणार की इथं लेफ्ट रोटेशन अप्लाय करायला लागेल की राईट रोटेशन अप्लाय करायला लागेल?
If right side is heavy, then use left rotation.
Simple logic will use. If height of the right side is greater than the left side, which rotation you need to apply?
Left.
Left. And if the height of the left subtree is greater than the right subtree, then which?
Right rotation.
Right rotation. म्हणजे लेफ्ट सबट्रीची हाईट जास्त असेल तर आपल्याला काय करावं लागेल? राईट
Right.
रोटेशन करावं लागेल. आणि जर राईटची हाईट जास्त असेल तर आपल्याला काय करावं लागेल? लेफ्ट रोटेशन करावं. Now how to perform the rotations here? Now here again, left right things you need to remember. Now when you are rotating this tree, so what you are doing in this method, if the right subtree is heavy or right skewed, then it is rotated to the left side to make the tree balanced, right? Now here, so we are shifting B as to the root, right? But at the same time, so A is converted to the child node, but A is shifted at the left side of the B. So why it is shifted at left side? A right side लाच का घेतलं नाही?
To balance height, both to left and right side.
A काय असणार आहे? ग्रेटर असणार आहे का लेस असणार आहे इथं?
Greater.
मग ग्रेटर एलिमेंट कुठल्या साईडला राहतात?
Right.
मग इथं राईट
Right.
घेतलेलं नाही.
But sir, B is B B man.
To balance the tree, so what we have done? So we have shifted the root to the left side, and this middle one we have shifted at root, right? So B we have shifted at up, and A we have shifted at left side. ठीक आहे. त्याला आपण लेफ्ट साइडला घेतलेला आहे आणि इथं आपण व्हॅल्यू कन्सिडर केली का? सिक्वेन्स कन्सिडर केला का? So we have not considered the sequence, right? So directly we have shifted. Now after that, in case of right rotation, so in this method, if the left subtree is heavy, so we'll see the example. So here you can see the examples of A, B, C. So what we have done now, A we have shifted at which side? Right side, and B we have shifted to the root, right? So this rotation is called as a right rotation or
Right rotation.
right rotation, right? So now all of you have got the concept left rotation and right rotation.
Yes, sir.
Okay.
Yes, sir.
Now consider the example, another example: 8, 6, 10, 4, 2, 5, and 7. So all these values are given. Now the above tree structure is balanced or unbalanced?
Unbalanced.
Unbalanced, right? So now start with the single rotation. So which rotation you need to apply here? Left or right?
Right rotation.
Right rotation.
Left rotation apply करावं लागेल की right rotation?
Right rotation.
Right rotation. But here, by mistakenly, I think left is written in the notes. Actually, we have performed right, but here in the notes, left is written. So please do the correction in the notes at the time of study. Now, start with the single rotation. Actually, we have performed the right, but here, why it is written left? आपण राईटच ऑपरेशन केले ना इथं. Here we have performed right, but by mistakenly in the notes I have written left, right? So do the correction in the notes. Now above tree structure start with the single rotation, that is left rotation with the following steps. Left rotation means, so which node you need to shift at the left? So 6 will become root, right? Now here all of you give attention. Now at right side who is there? 7. हा कुठल्या साइडला जाईल? 8 च्या left ला गेलेला आहे. So all of you remember. And this 10 will be as it is, and this 8 will be attached at right side of the 6. So we have performed right operation. So these things you need to remember. जो आपण रूटला नेणार आहे नोड 6 रूटला गेलेला आहे, right element will be considered as a left of the previous root, right? So here the 6 is shifted up and 8 will be shifted down one level, right? And after that, so 7 will be considered as a left of the 8, right? So here the rotation you need to understand. Now 6 becomes the new root. Node 8 takes the ownership of the node 6. Sorry. Node 6 takes the ownership of. No, so right. 7, 8 ला join झाल्यामुळे हे sentence लिहिलंय second, right? Good. The number which is in the right side of the 6 becomes the left side of the 8. So when 8 will take the ownership of 6, so at that time automatically the number which is in the right side of the 6, so that will become left side of the 8. So why? Because of the second step. Now next one is the.
हॅलो सर.
Yes.
सर ते मागचे हा सर तिथं 7 च्या जागी जर 11 असतं तर ते राईट साइडला गेलं असतं ना 8 च्या.
11 तिथं नसलंच असतं. ऍक्च्युली दिस इज द बायनरी सर्च ट्री. हे बायनरी सर्च ट्री तयार केलेले आहे आपण, कारण 11 ह्या 8 च्या या साइडला आलंच नसतं लेफ्टच्या, ते ऍक्च्युली राईट साइडला राहिलं असतं. लक्षात आलं का? 7 च्या ठिकाणी 11 येऊ शकत नाही, कारण इथं आपण बायनरी सर्च ट्री वापरलेली आहे. So already we have considered the sequence. या ठिकाणी ऑलरेडी आता 6 आहे, 7 आहे, 8 इथं आहे, 7च असणार आहे. या ठिकाणी दुसरी व्हॅल्यू असू शकते. 11 कुठं असणार आहे? At which place 11 will be there? 10 च्या कोणत्या साइडला असेल? या साइड.
Right side.
जर 10 इथं असेल, 11 इथं असेल, तर ट्री बॅलन्स्ड असेल का अनबॅलन्स्ड असेल? बॅलन्स्ड असेल. मग हे रोटेशन अप्लाय करायची गरज आहे का?
No, sir.
No, sir.
मग 7 च्या ठिकाणी आपण नाही कन्सिडर करू शकत. Next, left rotation. So first construct the AVL tree. So by considering these elements, so 8, 7, 12, 9, 14, 13, and 6. Sorry. So always, so when you are constructing the tree, so first element you are considering as a root node. So who is the root node here? 8 is the root node.
8.
After that 7. So where 7 will be inserted? At left or right? Left. At 12. Right. After that 9.
Left of 12.
Left.
Left of 12. 14.
Right of 12.
Right of 12.
13.
Left of 14.
14.
And 16.
Right of
14.
In this way, we have constructed the AVL tree first, right? Now, whatever the tree you have constructed, so this is the balanced or unbalanced?
Unbalanced.
So calculate the balance factor of the tree. What is the balance factor of the tree?
-2.
-2.
-2. Tree चा balance factor कुठल्या ह्याला consider करणार? So
Root.
balance factor of root. So what is the balance factor of the tree is -2. The above tree is not a balanced AVL tree. So again we need to apply which rotation you need to apply here?
Left
Left
rotation.
Left rotation.
Left rotation. Now here we have considered correct one. So previously here is the right one. So in the notes, so you can consider the corrections. Left rotation. Now how to apply the left rotation? So now 12 becomes the root node, right? Now when 12 becomes the root node, means node 8 takes the ownership of 12. Now 8 takes the ownership of 12 means, so what will be the change? 9 is attached to the right of the 8. So previously it was attached with the left of the 12. Left of the 12 च्या ठिकाणी तो कुठे जाणार आहे? Right of the 8, right? So when node 8 takes the ownership of 12, so when node 8 takes the ownership of 12, then left child of the 12 becomes the right child of the 8, right? So this is called as a left rotation. Now, two examples we have discussed related with the left rotation and right rotation. Now all of you have got the concept of left rotation and right rotation. इथपर्यंत
Yes, sir.
सर्वांच्या लक्षात आलंय?
Yes, sir.
Okay, good. Now next, construct the tree first. Is it visible to all?
Yes, sir.
Construct the tree first. So what is the first node here? First node क्या है?
8.
8.
8,
After that
7.
7. Next one is the, now all of you have dictate in your notebook. So otherwise, so whatever the examples we have discussed, now at least from here, you can write. Otherwise, so here I will explain. All of you have dictate the types of rotation first. Write down the definition: left rotation, right rotation. So for these three, so here you need to write. So practice is required. Otherwise, so theoretically you will be clear, but at the time of exam, sometimes you are not able to recall the concept. First, write down the types of rotation. Operations of AVLs. Now all of you have written definition. Next examples. Definition examples. पहिल्या पेज वर चालू केलं का नाही अजून? Definition झाली?
No, sir.
हा, okay. Dictate it fast. पूरी माइंड है नहीं था लोकल जो है ना सगळ्यांनी दोन डोस घेतली ना सर्टिफिकेट आहेत का सर्व सगळे इम्प्लिमेंटेशन होते ना 40 पहिल्या सेशनमध्ये कुठे झालेलं आहे हा इथपर्यंत लिहून घ्यायचं हा नेक्स्ट
Remember rotation concept.